Hey, what's going on, guys? My name is Zero Davila. Welcome back to Save Our System IT. Today I'll continue part number 20 of our Busybox series. Sync is a standard system call in the Unix operating system which commits to disk all data in the kernel file system buffers, meaning data which has been scheduled for writing via low-level I/O system calls. Note that higher-level I/O layers such as stdio may maintain separate buffers of their own. As a function in C, the sync call is typically declared as void. The system call is also available via a command line utility also called sync, and similarly named functions in other languages such as Perl, Node.js, and so on. The related system call fsync commits just the buffer data relating to a specified file descriptor. fdatasync is also available to write out just the changes made to the data in the file and not necessarily the file's related metadata. Unix systems typically run some kind of flush or update daemon, which calls the sync function on a regular basis. On some systems, the cron daemon does this, and on Linux, it's handled by the pdflush daemon. Buffers are also flushed when file systems are unmounted or remounted as read-only, for example prior to system shutdown. sysctl is an interface for examining and dynamically changing parameters in the BSD and Linux operating systems. The implementation mechanism in these two systems is very different. In Linux, the sysctl interface mechanism is also exported as part of the procfs under the sys directory. This difference means checking the value of some parameter requires opening a file in a virtual file system, reading its contents, parsing them and closing the file. The sysctl system call does exist on Linux, but does not have a wrapping function in glibc and is not recommended for use. In BSD, these parameters are generally objects in a management information base, or MIB, that describe tunnable limits such as the size of the shared memory segment, the number of threads the operating system will use as an NFS client, or the maximum number of processes on the system, or describe enable or disable behavior such as IP forwarding, security restrictions on the superuser, or debugging output. In computing, syslogd is a standard for message logging. It permits separation of the software that generates messages, the system that stores them, and the software that reports and analyzes them. Each message is labeled with a facility code, indicating the software type generating the message, and assigned a severity label. Computer system designers may use syslogd for system management and security auditing, as well as general information, analysis, and debugging messages. A wide variety of devices, such as printers, routers, and message receivers across many platforms, use the syslogd standard. This permits the consolidation of logging data from different types of systems in a central repository. Implementations of syslogd exist for many operating systems. tac, which is cat backwards actually, concatenates each file to standard output just like the cat command but in reverse, line by line printing the last line first. This is useful, for instance, for examining a chronological log file in which the last line of the file contains the most recent information. If no file is specified or if the file is specified as a hyphen, tac reverses the contents of the standard input. tel prints the last 10 lines of each file to standard output. With more than one file, it precedes each line of output with a header giving the file name. If no file is specified, or if file is specified as a dash, tel reads from standard input. If the first character of k, the number of bytes or lines, is a plus sign, tel prints the beginning with the kth item from the start of each file. Otherwise, tel prints the last k items in the file. And k may have a multiplier suffix for bytes, kilobytes, megabytes, gigabytes, and so on. With double hyphen follow or the hyphen f option, tel defaults to following the file's descriptor, which means that even if a tailed file is renamed, tail will continue to track its end. This default behavior is not desirable when you really want to track the actual name of the file, not the file descriptor. For example, in a log rotation. Use double hyphen follow equals name in that case. That causes tail to track the name file in a way that accommodates renaming, removal, and creation. The tar program is used to create, maintain, modify, and extract files that are archived in the tar format. Tar stands for tape archive. It's an archiving file format. tar was originally developed in the early days of Unix for the purpose of backing up files to tape-based storage devices. It was later formalized as part of the POSIX standard and today is used to collect, distribute, and archive files, while preserving file system attributes, such as user and group permissions, access and modification dates, and directory structures. The first argument to tar should be a function specification, either one of the letters capital A, C, D, R, T, U, or X, or one of the long function names. A function letter does not need to be prefixed with a dash, and may be combined with other single letter options. A long function name must be prefixed with a double dash. Some options take a parameter. With the single letter form, these must be given as separate arguments. With the long form, they may be given by appending an equal sign and then the value to the option. Taskset is used to set or retrieve the CPU affinity of a running process given its PID, or to launch a new command with a given CPU affinity. The CPU affinity is a scheduler property that bonds a process to a given set of CPUs on the system. A Linux scheduler will honor the given CPU affinity and the process will not run on any other CPUs. Note that the Linux scheduler also supports natural CPU affinity. The scheduler attempts to keep processes on the same CPU as long as practically possible for performance reasons. Therefore, forcing a specific CPU affinity is useful only in certain applications. The CPU affinity is represented as a bit mask, with the lowest order bit corresponding to the first logical CPU and the highest order bit corresponding to the last logical CPU. Not all CPUs may exist on a given system, but a mask may specify more CPUs than are present. A retrieved mask will reflect only the bits that correspond to CPUs physically on the system. If an invalid mask is given, one that corresponds to no valid CPUs on the current system, an error is returned. And the masks are typically given in hexadecimal. The T command is named after the T-splitter in plumbing, which splits water into two directions and is shaped like an uppercase T. T copies data from standard input to each file and also to standard output. In effect, T duplicates its input, routing it to multiple outputs simultaneously. So let's say we have the ls with the -1 option and we offer it as an argument the wildcard asterisk followed by .txt. We pipe that to the word count command with the -l option and pipe it again to the T command and offer it as an argument to the count.txt file. In this example, the ls command lists all files in the current directory that have the filename extension .txt, one file per line. This output is piped to word count, which counts the lines and outputs the number, and this output is piped to T, which writes the output to the terminal and also writes the same information to the file count.txt. If count.txt already exists, it's overwritten. And that's about it for today. Don't forget to like, share and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sysit.co. Again, that's www.sysit.co. Thanks for watching and have a nice day.